March 29, 1944. Venegono Inferiore airfield, northern Italy. The Luftwaffe ground crew supervisor froze mid-stride as an unmistakable silhouette emerged through the scattered clouds above the German-occupied airfield. A four-engine heavy bomber, its twin tails and high-mounted wings catching the late morning sun, descended steadily through 1,500 feet. For a moment, confusion rippled through the men who'd spent the last year learning to shoot down exactly this type of aircraft. Then someone shouted the obvious truth that changed everything. It was landing, not attacking, landing. The Consolidated B-24H Liberator, serial number 42-52106, call sign Sunshine, touched down on enemy territory with a grinding screech of tires against concrete. Inside the cockpit, Second Lieutenant William Hemphill and his co-pilot exchanged looks of dawning horror as they saw not Swiss neutrality markings, but German crosses painted on the buildings surrounding the runway. They had aimed for Switzerland, desperate after flak over Bolzano knocked out 2 engines. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. They had missed by 75 miles. The entire 10-man crew became prisoners within minutes. But their aircraft, completely intact and operational, was about to embark on a journey that would reveal to Luftwaffe engineers something they had consistently refused to believe about American industrial capabilities. The Americans had built a bomber with 3,000-mile range, and they had built 18,000 of them. The revelation came not all at once, but through months of systematic testing that forced German aviation specialists to confront an uncomfortable reality about the nature of modern warfare. Range had become the decisive factor in strategic bombing, and Germany had never seriously attempted to build anything approaching American long-range capabilities. This wasn't a failure of engineering skill or aerodynamic understanding. It was a fundamental misreading of what the war would become. And by 1944, when Sunshine arrived intact at Rechlin Testing Center, correcting that strategic error had become impossible. The story of captured B-24 Liberators in Luftwaffe service begins not with Sunshine, but 3 years earlier in the desperate summer of 1941, when the first Liberators entered Royal Air Force service flying maritime patrol missions over the Atlantic. German intelligence officers studying intercepted reports and examining wreckage from downed aircraft noted something remarkable about this new American bomber. Its range exceeded anything in European service by factors approaching 2 to 1. The numbers seemed impossible, yet they were verified through multiple independent sources. The Consolidated Model 32, as the manufacturer designated the design, emerged from specifications written in January 1939, when General Henry Arnold invited Consolidated Aircraft to produce something superior to Boeing's Flying Fortress. The company's president, Reuben Fleet, had recently visited Boeing's Seattle facility to examine B-17 production. Instead of accepting a license to build someone else's design, Fleet authorized his chief engineer, Isaac Ladden, to create an entirely new aircraft optimized around one critical requirement: maximum possible range with practical bomb load. Ladden's team made a decision that would define the B-24's character throughout its service life. They selected an unusual wing design created by David Davis, a freelance aeronautical engineer whose fluid foil concept promised dramatically reduced drag through unconventional airfoil geometry. Davis had designed his wing in reverse, starting with an ideal low-drag teardrop shape and then modifying it to generate lift rather than beginning with a lifting surface and trying to reduce its drag. The result was a high aspect ratio wing, long and relatively narrow, with a cross-section that maintained smooth airflow farther back from the leading edge than conventional designs. Wind tunnel tests at California Institute of Technology confirmed Davis's claims. The wing produced 20% less drag than standard NACA airfoils, while generating equivalent lift. This efficiency translated directly into range. Every gallon of fuel carried the aircraft farther. Every pound of structure allowed either more fuel or greater bomb load. The Davis wing would give the Liberator capabilities unmatched by any other heavy bomber in 1941, but it came with a cost that German test pilots would document extensively. The thin, high-mounted wing made the B-24 less robust than the B-17, more vulnerable to battle damage, harder to fly in formation, and unforgiving during emergency procedures. The prototype B-24 first flew on December 29, 1939, just 2 days before the end of the year, as required by contract specifications. Test pilots immediately confirmed both the advantages and challenges of the Davis wing design. The aircraft flew fast for a heavy bomber, cruising at speeds approaching 220 miles per hour. It climbed efficiently to altitudes exceeding 28,000 feet, and its range, even with limited internal fuel, exceeded 1,700 miles with full bomb load. But the high wing loading, 35% greater than the B-17, meant the Liberator required higher landing and takeoff speeds. The aircraft demanded constant attention in formation flying. Control forces were heavy at all airspeeds, and the shoulder-mounted wing position, necessary to provide ground clearance for the large bomb bays, meant the aircraft sat high on its tricycle landing gear. This made belly landings catastrophic and water ditchings nearly impossible to survive. German intelligence officers tracking American bomber development through 1940 and into 1941 noted these characteristics from interrogation reports and technical analyses of crashed aircraft. They understood the B-24 represented a different design philosophy than the B-17. Where Boeing's Fortress emphasized ruggedness and defensive firepower, Consolidated's Liberator prioritized range and payload. The distinction would prove strategically decisive. Early production Liberators went to Britain under Lend-Lease agreements beginning in 1941. RAF Coastal Command immediately recognized the type's potential for maritime patrol operations against German U-boats operating in the Atlantic. The standard Liberator, designated Mark I by the British, carried sufficient fuel for missions lasting 10 hours or more. Modified variants with additional fuel tanks and reduced defensive armament could remain airborne for 14 hours, patrolling vast areas of ocean previously beyond the reach of land-based aircraft. These very long-range Liberators began closing what naval strategists called the Mid-Atlantic Gap, a region beyond the effective range of shore-based aircraft where U-boats could operate on the surface without fear of air attack. Throughout 1942 and into 1943, Liberators flying from bases in Iceland, Newfoundland, and Northern Ireland systematically hunted German submarines, forcing them to remain submerged during daylight hours and drastically reducing their effectiveness. German naval intelligence analyzed this new threat with growing concern. The Liberator's range allowed it to appear hundreds of miles from shore, attacking U-boats at the farthest extent of their patrol areas. Submarine captains who had grown accustomed to relative safety in the deep Atlantic suddenly faced persistent aerial surveillance and attack throughout their operational zones. Losses mounted steadily. By mid-1943, German submarine command was losing boats faster than shipyards could replace them, but the maritime patrol mission represented only one application of the B-24's extraordinary range. American strategic planners recognized the type's potential for long-range bombing operations that would carry the war directly to enemy industrial centers across vast distances. Throughout 1942, as American forces deployed to Britain and North Africa, Liberator bomb groups began training for missions that would test the aircraft's capabilities to their absolute limits. The first B-24 to fall into German hands intact arrived through peculiar circumstances. On February 20, 1943, a B-24D from the 98th Bomb Group, serial number 4-1-2-3-6-5-9, nicknamed Blonde Bomber 2, sustained damage during a mission against Naples. The crew, disoriented and low on fuel, mistook the Sicilian airfield at Pachino for their intended destination at Malta. They landed on enemy-controlled territory, believing themselves safe. Italian forces immediately seized the aircraft and its crew. The bomber, though damaged, remained structurally intact and repairable. Italian engineers at the Guidonia Test Center spent several months examining the Liberator, documenting its systems and conducting limited flight tests. In June 1943, diplomatic arrangements transferred Blonde Bomber 2 to Germany. Luftwaffe pilots ferried the aircraft via Munich to Rechlin Testing Center, where it would undergo the most thorough evaluation any captured American bomber had received. German test pilots approached the B-24 with professional curiosity, tempered by skepticism born from years of propaganda emphasizing American industrial crudity. The prevailing view held that American aircraft represented mass production compromises, acceptable in quantity but inferior in refinement to German designs that emphasized quality and performance. The Liberator would systematically demolish these comfortable assumptions through direct experience that could not be dismissed or explained away through ideological reasoning. The first comprehensive examination of Blonde Bomber 2 occurred throughout July and August 1943 at Rechlin. Teams of engineers crawled through every section of the aircraft, documenting construction methods, measuring structural components, analyzing material selections, and testing systems under various conditions. What they discovered challenged fundamental German assumptions about American manufacturing capabilities and strategic priorities. The fuselage construction revealed sophisticated approaches to stressed skin design that distributed loads efficiently throughout the structure. Large panels with minimal compound curves simplified manufacturing while maintaining strength. Standardized fasteners throughout the aircraft reduced inventory requirements and simplified assembly. Modular subassemblies allowed parallel manufacturing of major components that came together during final assembly with minimal custom fitting required. The bomb bay design particularly impressed German engineers. Twin bays, each matching the size of the B-17's single bay, provided total capacity of 8,000 pounds of ordnance in short-range configurations. Unusual roller-type doors retracted into the fuselage sides rather than opening outward, reducing drag and eliminating the complex mechanism required for traditional bomb bay doors. The design allowed rapid ordnance loading and reliable operation even after battle damage. But the feature that would prove most significant to German strategic assessments was the fuel system. The B-24D carried 3,614 gallons of aviation fuel in self-sealing tanks distributed throughout the wings and fuselage. This represented 50% greater internal capacity than comparable German bombers. With external drop tanks, total fuel load exceeded 5,000 gallons. The implications were staggering to German planners who understood range calculations. A Liberator could fly missions exceeding 2,000 miles. A radius with practical bomb loads. It could patrol maritime areas for 10 hours or more. It could escort convoys across the Atlantic. It could strike targets deep in enemy territory and return to bases hundreds of miles distant. No German bomber possessed even half this operational radius. The Heinkel, He-177, Germany's only operational four-engine heavy bomber, managed barely 800 miles radius under optimal conditions. Most missions required forward staging bases or accepting shorter range targets. The asymmetry revealed a fundamental difference in strategic vision. American planners had designed the B-24 specifically for global warfare, requiring intercontinental deployment and operations across vast ocean distances. German aviation doctrine emphasized tactical support for ground forces operating in European theaters where distances rarely exceeded a few hundred miles. This doctrinal decision had shaped German bomber development throughout the 1930s and into the war years. By 1943, changing that fundamental orientation had become impossible given resource constraints and the immediate demands of fighting on multiple fronts. Test flights of Blonde Bomber 2 throughout August and September 1943 confirmed what the structural analysis suggested. The Davis wing delivered its promised efficiency. German test pilots, flying carefully planned missions to measure performance across various flight regimes, documented cruise fuel consumption substantially lower than German bombers of equivalent weight. At optimal cruise altitude near 25,000 feet and cruise speed of 215 miles per hour, the Liberator consumed approximately 350 gallons per hour total across all four engines. The mathematics were straightforward and devastating to German strategic calculations. With 3,600 gallons internal fuel, the aircraft could remain airborne for 10 hours. At cruise speed of 215 miles per hour, that represented operational range approaching 2,100 miles before accounting for climb, combat maneuvering, or reserve fuel. With external tanks adding 1,500 gallons, total endurance exceeded 14 hours, and range approached 3,000 miles under ideal conditions. German long-range bombers achieved nothing remotely comparable. The Focke-Wulf 4-200 Condor maritime patrol aircraft managed 2,000-mile range, but carried minimal bomb load and lacked defensive armament for contested airspace. The Heinkel He 177, plagued by chronic engine fires from its unusual coupled power plant design, rarely exceeded 1,200-mile range with practical weapons loads. No other German design even approached these figures. The gap represented more than engineering differences. It reflected fundamentally different understandings of what modern strategic warfare required. American doctrine emphasized projecting power across global distances, striking enemy industrial capacity from bases established across oceans, maintaining supply lines spanning continents. German doctrine focused on continental warfare within Europe, where forces could operate from nearby bases with tactical air support, providing immediate battlefield assistance. Neither approach was inherently superior in abstract terms. But by 1943, the war had evolved into precisely the global attritional struggle for which American doctrine prepared, and German forces remained unprepared. Liberators flying from Britain could strike any target in Western and Central Europe. Liberators operating from Italy ranged across Southern Europe and the Balkans. Liberators based in North Africa reached targets throughout the Mediterranean basin. German bombers, lacking equivalent range, could not reciprocate by striking American industrial capacity across the Atlantic. The power plant installation on the B-24 revealed American approaches to engine management and systems integration that impressed German engineers, despite their familiarity with advanced aviation technology. 4. Pratt & Whitney R1830. Twin Wasp radial engines, each producing 1,200 horsepower at rated altitude through turbo supercharging, drove the bomber through the air with surprising efficiency. The engines were mature, reliable designs that had entered production years before the war. Their installation on the Liberator emphasized maintainability and operational availability, rather than maximum performance. Each engine mounted in a nacelle suspended below and ahead of the wing leading edge. This position provided excellent access for maintenance crews working under field conditions. Cowling panels opened in sections that exposed the entire engine and its accessories, without requiring specialized tools or extensive disassembly. The turbo supercharger, mounted in the bottom rear of each nacelle, could be inspected and serviced rapidly. Oil tanks, fuel lines, electrical connections, and control linkages were logically arranged and clearly labeled. German maintenance personnel examining the Liberator's power plant installation noted the striking contrast with German practice. Messerschmitt and Focke-Wulf fighters often required extensive disassembly to access engine components for routine maintenance. Critical systems were tightly packaged into minimal space, prioritizing aerodynamic efficiency over maintenance accessibility. This design philosophy worked adequately when skilled mechanics had ample time and proper facilities. It became problematic under field conditions where maintenance teams worked in mud and cold, with limited tools and constant time pressure. The American approach accepted slightly greater drag from larger nacelles in exchange for maintenance access that kept aircraft operational. A Liberator with minor engine problems could be repaired in hours at forward airfields. Comparable German aircraft often required transport to depot facilities for work that field crews could not accomplish. The operational availability rates reflected this fundamental design difference. American bomb groups maintained higher percentages of aircraft in serviceable condition despite flying more frequent missions. But the most significant revelation from testing Blonde Bomber 2 involved not the aircraft itself, but the production capacity it represented. German intelligence had tracked American aircraft production through various sources throughout 1942 and into 1943. The numbers seemed impossibly high. Surely there were errors in translation, misunderstandings about different counting methods, propaganda inflation, designed to intimidate rather than inform. The captured Liberator provided physical evidence that could not be dismissed. Every component bore manufacturer stamps, serial numbers, production dates, and quality control markings. By examining these carefully and cross-referencing them against intelligence databases, German analysts reconstructed a detailed picture of American B-24 production that confirmed their worst fears. The numbers were real. The Americans were building heavy bombers at rates exceeding all German aircraft production combined. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Consolidated Aircraft's facility in San Diego produced approximately 35 Liberators monthly by mid-1943. This represented the original manufacturing source, where experienced workers assembled aircraft using established production methods. But the Americans had not stopped there. They had established 4 additional production lines at facilities across the United States, each eventually producing comparable or greater numbers than the San Diego plant. Douglas Aircraft in Tulsa, Oklahoma, built modified B-24 variants at increasing rates throughout 1943. North American Aviation in Dallas, Texas, produced additional airframes. Fort Worth, Texas, hosted another consolidated facility that rivaled the San Diego output. But the installation that truly staggered German observers was Ford Motor Company's Willow Run plant in Michigan. Ford had constructed the largest aircraft manufacturing facility in the world, specifically to mass-produce Liberators using automotive assembly line techniques adapted to aviation. The plant, over a mile long, employed tens of thousands of workers organized into multiple shifts that operated continuously. By late 1943, Willow Run was producing one complete B-24 every 63 minutes at peak efficiency. The assembly line delivered over 400 Liberators monthly from this single facility alone. Total American B-24 production during 1943 exceeded 8,000 aircraft. Throughout 1944, production would peak at over 9,000. By war's end, American manufacturers would complete over 18,400 Liberators of all variants. This represented more heavy bombers than Germany produced of all types throughout the entire war. A single American bomber design, manufactured by 5 companies in enormous facilities, exceeded Germany's total strategic bombing capability through industrial organization alone. The psychological impact on German aviation specialists who understood these figures cannot be overstated. They had entered the war confident in German engineering superiority and industrial capabilities. The captured Liberator proved American engineering equaled or exceeded German standards in the areas that mattered strategically, and American industrial capacity exceeded German production by factors that made any discussion of quality differences strategically irrelevant. Even if German bombers were twice as effective per aircraft, which they demonstrably were not, American numerical advantage would still prove overwhelming. Following evaluation at Rechlin, Blonde Bomber 2 underwent repair and modification for operational service with Kampfgeschwader 200, the Luftwaffe's special operations unit responsible for clandestine missions, long-range reconnaissance, and testing captured aircraft. Throughout autumn 1943, the bomber received dark camouflage paint for night operations, specialized radio equipment for electronic reconnaissance, and KG-200 identification markings. The unit operated an eclectic collection of captured Allied aircraft alongside specialized German types. Several B-17 Flying Fortresses flew reconnaissance missions over Allied territory where their silhouettes might be mistaken for friendly aircraft returning from bombing missions. Now they added the Liberator's capabilities to their stable, particularly valuing its extraordinary range for deep penetration missions behind enemy lines. But the most thoroughly documented captured Liberator arrived at Rechlin 9 months after Blonde Bomber 2, following a navigation error that would become one of the more remarkable stories of mistaken identity during the war. On March 29, 1944, Second Lieutenant William Hemphill piloted B-24H Sunshine, serial number 42-52106, on a maximum effort bombing mission against marshalling yards at Bolzano near the Italian-Austrian border. The mission went badly from the start. Sunshine had already completed 5 combat missions with the 719 Bomb Squadron, 449th Bomb Group, 15th Air Force, operating from Grottaglie, Italy. The aircraft was war-weary, having sustained minor battle damage on previous missions that ground crews repaired using whatever spare parts could be scrounged from more seriously damaged Liberators. On March 29th, the bomber was marginal for flight status, but maximum effort meant every aircraft that could possibly fly would fly. Ground crews worked through the night, replacing a damaged engine with components cannibalized from other wrecks. The formation encountered heavy and accurate anti-aircraft fire over Bolzano. Multiple shells struck Sunshine, knocking out 2 engines and damaging fuel lines. The bomber immediately lost power and fell behind the formation, trailing smoke and losing altitude. Hemphill faced the impossible choice, familiar to countless bomber pilots throughout the war. Attempting to reach friendly territory across the Mediterranean meant certain death for a crippled aircraft that could barely maintain level flight. Bailing out over northern Italy meant imprisonment but survival, or they could try reaching neutral Switzerland just 75 miles to the north. Hemphill chose Switzerland. The crew jettisoned everything movable to reduce weight, including ammunition, oxygen bottles, and personal equipment. They nursed the dying bomber northwest, trading altitude for distance, watching the mountains rise ahead through broken cloud cover. When they spotted an airfield through a gap in the clouds, they committed to landing immediately before losing the remaining engines. The field looked right. The geography seemed correct. They were exhausted, frightened, and desperate. They landed at Venegono, believing themselves safe. The German and Italian ground crew reception committee quickly corrected their misapprehension. Sunshine had landed 75 miles short of Switzerland at a Luftwaffe airfield. The entire crew became prisoners within minutes. But their aircraft, aside from battle damage and the failed engines, remained structurally intact and repairable. Luftwaffe intelligence officers recognized the prize immediately. This was not a crashed wreck scattered across a hillside. This was a complete, relatively undamaged B-24H, one of the latest production variants with improved nose armament and updated systems. German recovery specialists transported Sunshine to Rechlin within days, understanding that captured American bombers provided intelligence value far exceeding their potential. Operational usefulness. By April 1944, the bomber had begun systematic testing that would continue through the summer. Every system received detailed evaluation. Engineers measured, photographed, and documented every component. Test pilots flew carefully planned missions exploring the B-24H's performance across its complete operational envelope. The H model differed from earlier Liberators in several significant ways. The nose turret, electrically powered and mounting 250 caliber machine guns, provided frontal defensive coverage that earlier models lacked. Total defensive armament increased to 10 50 caliber guns positioned to provide overlapping fields of fire from all angles. The aircraft carried 7,500 rounds of ammunition distributed across all gun positions, allowing sustained defensive engagement throughout long missions. Maximum takeoff weight had grown to 65,000 pounds, reflecting both structural strengthening and more powerful engines. The Pratt and Whitney R183065 engines installed in the H model produced 1,200 horsepower each at rated altitude, driving 4-blade Hamilton standard propellers. Total available power of 4,800 horsepower drove the massive bomber to maximum speeds, approaching 300 miles per hour at optimal altitude and cruise speeds of 215 miles per hour during long-range missions. German test pilots documented handling characteristics that confirmed American design priorities. The B-24 flew fast for a heavy bomber, but demanded constant attention in formation. Control forces were heavy across all speeds, requiring physical strength during extended missions. The high wing loading made low-speed handling challenging, particularly during landing approaches where the aircraft required careful speed management to avoid dangerously high sink rates. But the feature that consistently dominated German evaluation reports involved the range capabilities that set the Liberator apart from any German bomber in operational service. With 3,600 gallons internal fuel plus 1,500 gallons in external drop tanks, Sunshine could theoretically fly missions approaching 3,000 miles under optimal conditions. Even accepting realistic factors including climb, combat maneuvering, weather diversions, and mandatory fuel reserves, operational range exceeded 2,500 miles with practical bomb loads. Consider what this meant strategically. A B-24 based in Britain could strike targets anywhere in Western and Central Europe and return to England. A Liberator operating from Italy could reach Ploesti, Vienna, Munich, or any target in Southern and Central Europe. Liberators flying from Pacific Island bases could strike Japanese positions across hundreds of miles of ocean. The aircraft projected American strategic bombing capability across distances German forces could not match or reciprocate. The strategic implications extended beyond simple reach. Range determined operational flexibility in ways that affected every aspect of bomber employment. Short-range bombers required forward bases near target areas, making them vulnerable to enemy attack and dependent on extended supply lines. Long-range bombers could operate from secure rear areas, concentrating at heavily defended bases where maintenance facilities, supply depots, and training infrastructure could be properly established. German bombers attacking Britain required bases in France or the Low Countries. When Allied forces invaded Normandy in June 1944, German tactical air support units lost their forward fields and fell back into Germany proper. Their reduced range immediately constrained operations against the invasion beaches. American and British bombers, meanwhile, struck targets throughout Germany from bases in England and Italy that remained far beyond German reach. The asymmetry proved strategically decisive. Germany could not strike American industrial capacity. The United States could systematically destroy German war production. German bomber forces declined throughout 1944, not primarily through combat attrition, but through resource allocation. Fighting defensively against overwhelming Allied air superiority consumed fighters, fuel, and pilots faster than German industry could regenerate losses. Strategic bombing became a luxury Germany could not afford. Air defense became existential necessity. But understanding the problem did not enable solutions. German aviation industry could not simply begin producing long-range heavy bombers in 1944 when every available resource supported fighter production desperately needed to defend against Allied bomber streams. Even if German factories could have manufactured Liberator equivalents in useful numbers, which was highly doubtful given resource constraints and competing priorities, training crews and establishing operational infrastructure required years Germany no longer possessed. Following evaluation at Rechlin, Sunshine received modifications for operational service with KG-200. The bomber underwent extensive work at Venegono, the Luftwaffe's radio and radar research center, where technicians installed specialized electronic equipment for night intruder missions. The Meadow-Berlin radar system, mounted in the aircraft's nose section, allowed German operators to detect, track, and record data about RAF bomber formations flying night missions over Germany. The mission concept exploited the Liberator's twin-tail configuration, which from certain angles resembled British four-engine bombers like the Lancaster and Halifax. Under cover of darkness, the captured B-24 would infiltrate RAF bomber streams, flying close enough to individual aircraft to record their heading, airspeed, altitude, and formation position, using the specialized radar equipment. This intelligence allowed Luftwaffe night fighter controllers to predict bomber routes and target selections, vectoring interceptors more effectively. The tactic worked for several months throughout summer and autumn 1944. RAF crews occasionally reported strange aircraft in their formations, but could not positively identify them in darkness. The psychological impact was significant. British bomber crews grew increasingly paranoid about German infiltration of their formations, suspecting every nearby aircraft might be an enemy intruder. The uncertainty degraded morale and increased stress during already terrifying missions over heavily defended German targets. But operational employment of captured bombers carried substantial risks that ultimately limited their effectiveness. Sunshine flew night missions over German-controlled territory, where friendly forces might mistake it for an enemy bomber, despite identification markings and careful coordination with air defense networks. On April 6, 1945, during a ferry flight from Hildesheim to Bavaria, German anti-aircraft gunners opened fire on the Liberator they could not positively identify in poor visibility. The aircraft went down, destroyed by the same forces it had served for nearly a year. The ironic end illustrated the fundamental problem with operating captured enemy aircraft. Even with German markings, careful mission planning, and coordination with friendly forces, the aircraft remained dangerous to its own side. Mistakes happened constantly under combat conditions. Nervous gunners fired first and confirmed identifications later. Fighter pilots attacked anything resembling enemy bombers, regardless of markings half glimpsed through clouds or darkness. Flying captured aircraft meant risking death from friendly fire as much as enemy action. Yet KG-200 continued operating multiple captured B-24 seconds throughout 1944, despite these risks. The intelligence value justified the danger for the specialized missions only these aircraft could accomplish. At least 3 Liberators served with the unit at various times, possibly more depending on operational requirements and aircraft availability. But by early 1945, as Allied ground forces advanced into Germany from both east and west, maintaining specialized operations became progressively more difficult. Fuel shortages grounded aircraft, regardless of airworthiness. Spare parts became impossible to obtain as Allied bombing systematically destroyed German transportation infrastructure. Forward bases fell to advancing armies, forcing constant retreats into progressively smaller areas. Experienced crews died or were captured faster than replacements could be trained. The sophisticated infrastructure required for intelligence operations collapsed under the weight of comprehensive military defeat. The technical intelligence gathered from captured Liberators documented American capabilities German forces could not match, but provided no path toward countering those advantages. German engineers understood exactly how the B-24 achieved its remarkable range. The Davis wing design principles could be replicated. The efficient power plant installation was straightforward. The fuel capacity calculations were simple mathematics. None of this knowledge helped because Germany lacked the resources, time, and strategic situation to implement solutions. Developing new long-range bomber designs required years of development, testing, and production ramp-up. Germany had perhaps months before inevitable defeat. Even if new designs could be magically completed overnight, producing them in meaningful numbers demanded industrial capacity, fully committed to fighter production, and replacement of catastrophic losses across all fronts. The fuel required to operate heavy bombers on strategic missions did not exist. Germany's synthetic fuel production capacity was being systematically destroyed by Allied strategic bombing throughout 1944. Training crews for long-range bombing missions took 8 months minimum under peacetime conditions with adequate fuel for instruction. By 1944, Luftwaffe training programs had been slashed to minimum hours dictated by desperate pilot shortages. New fighter pilots arrived at operational units with barely 100 hours total flight time and virtually no combat training. Bomber crew training would have required substantially more instruction time Germany could not provide. Most fundamentally, developing strategic bombing capability in 1944 made no military sense given Germany's strategic position. The nation fought defensively on multiple fronts against enemies with overwhelming material superiority. Offensive strategic bombing required air superiority, secure bases, established logistics, trained crews, reliable intelligence, and sustained operations over months and years. Germany possessed none of these prerequisites and no realistic path to acquiring them. The captured Liberators thus became exhibits in a museum of German military failure, demonstrating capabilities the Reich should have developed years earlier, when resources and strategic position would have allowed meaningful implementation. By 1941, when the first B-24 seconds entered service with RAF Coastal Command, German aviation industry should have possessed heavy bombers with equivalent range flying operational missions. By 1942, when American strategic bombing began against occupied Europe, Germany should have reciprocated by striking targets in Britain, with aircraft capable of reaching anywhere in the British Isles from bases in France or Norway. The failure to develop these capabilities reflected not engineering deficiency, but strategic short-sightedness, rooted in fundamental misunderstandings about the nature of modern industrial warfare. German military planning through the 1930s emphasized quick, decisive campaigns in Barizo, Europe, supported by tactical aviation and armored forces. The doctrine worked brilliantly against Poland, France, and the Low Countries. It failed catastrophically against the Soviet Union's endless spaces and massive manpower reserves. It proved equally inadequate against Britain's island geography protected by the English Channel, and against America's industrial capacity insulated by vast oceans. Strategic bombing doctrine required thinking in terms of years-long campaigns, systematically destroying enemy industrial capacity through sustained operations, regardless of immediate battlefield situations. German military culture, shaped by continental warfare traditions emphasizing decisive battlefield victories, never fully embraced this approach. Even Luftwaffe commanders who understood strategic bombing theory in abstract terms consistently prioritized tactical support for ground forces when resource allocation decisions forced choices between competing requirements. The result was a Luftwaffe optimized for campaigns Germany had already won in 1940, while remaining unprepared for the attritional industrial struggle that defined warfare from 1942 onward. Tactical bombers like the Junkers Ju-88 and Heinkel He-111 served effectively supporting ground operations throughout the Battle of France and early Eastern Front campaigns. They became progressively obsolescent as the war evolved into strategic contests, where range, payload, and defensive armament determined outcomes. Germany's single attempt at four-engine heavy bomber development, the Heinkel He-177, illustrated the consequences of confused priorities and inadequate industrial capacity. The aircraft featured an unusual coupled engine design, placing two engines side by side in each nacelle, driving a single propeller through complex gearing. The arrangement theoretically provided heavy bomber power while presenting fighter-like frontal profile with reduced drag. In practice, the coupled engines generated catastrophic overheating that caused frequent fires. Mechanical reliability remained poor throughout the aircraft's service life. Production never exceeded 1,200 across all variants, and many units refused to accept the type after experiencing operational disasters. Had Germany committed to conventional four-engine bomber development in the late 1930s, using proven uncoupled engine installations, Luftwaffe bomb groups might have deployed aircraft with capabilities approaching early Liberators by 1941. Even with half the B-24's range, German heavy bombers with 1,000-mile radius would have allowed sustained operations against British industrial centres from French bases. The strategic impact could have been significant during the critical period when Britain fought alone before American entry into the war. But by 1944, when captured Liberators demonstrated what Germany should have built years earlier, correcting the strategic error had become impossible. The nation's aviation industry struggled to maintain fighter production against relentless Allied bombing, fuel shortages grounded aircraft regardless of availability. Pilot training collapsed under impossible demands for immediate replacements to fill gaps left by catastrophic attrition. Even if Germany could have somehow manufactured heavy bombers in useful numbers, operating them required resources and infrastructure that no longer existed. German test pilots who flew captured B-24 seconds extensively developed professional respect for American engineering achievement while recognizing the futility of their situation. The Liberator represented sophisticated design executed with manufacturing excellence, integrating advanced technologies into a coherent weapons system optimized for strategic mission requirements. The Davis wing demonstrated aerodynamic efficiency through unconventional design approaches. The power plant in installation emphasized operational availability over maximum performance. The fuel capacity enabled mission profiles German bombers could not attempt. The defensive armament, though less concentrated than the B-17's famous firepower, provided adequate coverage from most attack angles. These were not crude, mass-produced machines reflecting American industrial simplicity, as propaganda suggested. They were carefully engineered aircraft incorporating design decisions that prioritized operational effectiveness over abstract performance maxima. American engineers had made different choices than their German counterparts, optimizing for different requirements dictated by different strategic circumstances. Neither approach was inherently superior, but by 1944 the American choices had proven strategically correct, while German decisions led toward comprehensive defeat. The production capacity represented by captured Liberators troubled German analysts more than any technical feature. 18,000 heavy bombers exceeded Germany's total production of all aircraft types during equivalent periods. Ford's Willow Run plant alone manufactured more B-24 seconds than Germany produced four-engine bombers of all types throughout the entire war. The disparity reflected industrial capacity differences that technology or tactics could not overcome. American factories operated without disruption by enemy bombing, supplied by transportation networks immune to interdiction, employing workers who lived without constant fear of air raids destroying their homes. Raw materials arrived through supply chains stretching across continents and oceans that American naval and air power protected. Subcontractors produced components to standardized specifications that ensured interchangeability across different assembly plants. Quality control systems maintained consistent manufacturing standards despite employing hundreds of thousands of workers, including many with no previous industrial experience. German industry operated under precisely opposite conditions throughout 1943 and 1944. Allied strategic bombing systematically destroyed factory capacity, killed skilled workers, severed transportation networks, and disrupted supply chains. Raw material shortages forced use of substitute materials with inferior properties. Component standardization collapsed as dispersed production using improvised facilities and forced labor-produced parts requiring extensive hand-fitting during assembly. Quality declined dramatically as experienced workers died or were drafted, while replacements received minimal training before entering production lines. The captured liberators demonstrated these industrial differences through countless small details, German engineers noted during teardown inspections. Components fit together precisely without gaps or misalignment. Fasteners throughout the aircraft were uniform standardized types. Weld quality was consistently high. Paint finishes were smooth and even. Panel gaps were minimal. The aircraft looked and felt like a product of sophisticated industrial processes, operating under stable conditions with adequate resources and skilled labor. Late-war German aircraft increasingly showed evidence of industrial distress. Panels fit poorly with visible gaps. Mixed fastener types appeared throughout single airframes as standard components became unavailable. Welds were rough and inconsistent. Paint was thin and uneven when available at all. These were not design failures or engineering deficiencies, but symptoms of an industrial base collapsing under sustained attack while operating far beyond normal capacity, using inadequate resources and poorly trained workers. No amount of individual skill or courage could overcome such comprehensive material disadvantage. German fighter pilots achieved remarkable success against heavy bomber formations through superior training and aggressive tactics. But they could not shoot down liberators faster than American factories built replacements. They could not prevent damaged bombers from reaching safe altitude and returning to bases where repair facilities rebuilt them for future missions. They could not stop the systematic destruction of German industrial capacity that progressively reduced their own aircraft availability, fuel supplies, ammunition stocks, and replacement parts. The strategic bombing campaign succeeded not through technological superiority or tactical brilliance, but through relentless application of overwhelming industrial capacity. American forces could sustain losses that would have grounded any other air force. They could replace damaged aircraft within days or weeks. They could train new crews in numbers sufficient to maintain operational strength despite significant casualties. They could deliver ordnance tonnages that accumulated over months and years to systematically destroy target sets across entire industrial regions. By summer 1944, when Sunshine flew night intruder missions with KG-200, the outcome of the air war over Europe was no longer in doubt. German industry produced fewer aircraft than losses through all causes required for replacement. Pilot training could not regenerate attrition rates approaching 50% in some units. Fuel shortages limited operations regardless of aircraft availability. The transportation infrastructure supporting military operations degraded under sustained bombing faster than repair crews could restore it. The captured B-24 seconds had taught Luftwaffe engineers everything worth knowing about American long-range bomber capabilities. They understood the Davis wing's aerodynamic efficiency. They recognized the sophisticated manufacturing processes that enabled mass production without compromising quality. They documented the fuel capacity and engine installation that provided 3,000-mile range. They analyzed the defensive armament and structural design that allowed aircraft to survive battle damage and return home. They calculated the production rates representing industrial capacity Germany could not match through any realistic means. None of this knowledge enabled effective countermeasures, because the fundamental problem was not technical, but strategic and industrial. Germany had entered a global attritional war without the industrial capacity, resource base, or strategic depth required to prevail against opponents who possessed all three advantages. American industry could build bombers faster than German forces could destroy them. American training programs could replace crew losses indefinitely. American logistics could sustain operations across oceans and continents that isolated German forces from any possibility of reciprocal attack. The Liberator's 3,000-mile range represented not just technical achievement but strategic vision implemented through industrial capacity. American planners had understood by the late 1930s that future warfare would require projecting power globally across distances measured in thousands of miles rather than hundreds. They designed aircraft specifically for these requirements and built industrial infrastructure capable of producing them in quantities measured in tens of thousands rather than hundreds. German aviation development had optimized for different requirements, reflecting different strategic assumptions. Continental warfare in Europe required tactical bombers supporting ground forces operating within a few hundred miles of bases. This doctrine worked brilliantly through 1940, when Germany fought enemies unprepared for modern mechanized warfare. It failed completely once the war evolved into the global industrial struggle that America's geography, resources, and industrial capacity allowed it to win through material attrition. One incident from Sunshine's operational career with KG-200 illustrates both the synthesized capabilities German forces gained from captured aircraft and the fundamental futility of their situation. During a night intruder mission in August 1944, the B-24 successfully infiltrated an RAF bomber stream heading toward Munich. The Meadow-Berlin radar tracked dozens of heavy bombers, recording their courses, airspeeds, and altitudes. The intelligence reached Luftwaffe night fighter controllers who vectored interceptors toward the stream, achieving several successful engagements that destroyed multiple bombers. The mission succeeded tactically. German night fighters downed 8 RAF aircraft that evening, killing or capturing over 50 British aircrew. The intelligence gathered by Sunshine contributed directly to this result. From a tactical perspective, the captured Liberator's employment achieved its objective. But strategically, the evening's success changed nothing. The RAF lost 8 bombers from a force of over 500. American factories were building more B-24 seconds every hour than Germany destroyed that entire night. British and American training programs graduated sufficient new crews weekly to replace all casualties with reserves remaining. The following night, another RAF bomber force struck different targets with comparable strength. The night after that, American bombers from the 8th and 15th Air Forces hit targets in daylight with fighter escort. The campaigns continued relentlessly, night after night, week after week, month after month. Individual German successes, even when multiplied across hundreds of engagements, could not halt or even significantly slow the systematic destruction of German war-making capacity. By October 1944, Germany's synthetic fuel production had declined to 30% of peak capacity. The Luftwaffe could barely fuel defensive operations against Allied bomber formations. Strategic bombing missions became impossible dreams regardless of theoretical bomber availability. Pilot training programs collapsed as flight schools lacked fuel for instruction. Experienced pilots flew multiple missions daily until killed or wounded because inadequate reserves prevented operational rotation. The entire military infrastructure supporting aviation operations degraded toward comprehensive failure. The captured Liberators continued flying specialized missions until fuel shortages, spare parts exhaustion, and advancing Allied ground forces made operations impossible. Sunshine's destruction in April 1945 by German anti-aircraft fire represented an appropriate ending for aircraft whose entire operational career symbolized German desperation and the futility of tactical success. Amid strategic collapse, the bomber had provided useful intelligence and demonstrated capabilities, but ultimately changed nothing about outcomes determined by industrial capacity and strategic position. Other captured B-24 met similar fates, as Germany's military situation deteriorated toward final collapse. Some were destroyed during Allied bombing raids against remaining Luftwaffe airfields. Others were abandoned and deliberately demolished as German forces retreated ahead of advancing armies. A few possibly survived until war's end and were captured by Allied forces moving into Germany, though documentation remains fragmentary for the chaotic final weeks. The technical data gathered from examining captured liberators survived in reports scattered across archives after the war. Allied intelligence teams recovered thousands of pages of German aircraft evaluation documents from Rechlin and other testing facilities. These reports confirmed that Luftwaffe engineers had thoroughly understood American bomber capabilities and had documented them with characteristic German thoroughness. The knowledge had proven strategically useless because understanding enemy advantages does not eliminate them when the underlying causes involve industrial capacity and resource availability, beyond any possibility of matching. Post-war aviation development incorporated lessons from captured aircraft evaluations conducted by all sides during the conflict. The Davis wing's aerodynamic efficiency influenced several post-war transport designs, seeking maximum range and fuel economy. American engineers studied captured German jets and rockets, incorporating advanced German research into Cold War aircraft development. Soviet designers examined American bombers extensively, leading to aircraft like the Tupolev Tu-4 that closely resembled the B-29 Superfortress. The technical exchange, facilitated through wartime captures and post-war intelligence gathering, accelerated aviation progress beyond what any single nation could have achieved working independently. But the fundamental lesson from captured liberators involved not technology but strategic planning and industrial organization. The B-24's 3,000-mile range represented foresight that anticipated global warfare, requiring intercontinental operations years before such conflicts materialized. American planners made correct strategic assessments in the late 1930s and built industrial infrastructure capable of implementing those plans through mass production of sophisticated aircraft. German planners made different assumptions that proved catastrophically wrong once the war evolved beyond their initial strategic calculations. The 18,000 Liberators built during the war represented not just manufacturing capacity, but strategic vision and industrial organization, working in concert toward clearly defined objectives. Every aircraft embodied decisions made years earlier about what kind of war America might fight and what capabilities would be required to prevail. The range wasn't accidental or fortuitous. It was deliberate design responding to strategic requirements identified through systematic planning and implemented through industrial capacity, built specifically for this purpose. Germany never seriously attempted equivalent industrial mobilization for long-range strategic bombing, because German strategic planning never anticipated fighting the kind of war that actually occurred. The mistake became apparent by 1941, but could not be corrected given resource constraints and immediate demands of fighting on multiple fronts. By 1943, when captured B-24 provided physical evidence of American capabilities, rectifying German shortcomings had become impossible. The story ends where it began, in the sky over Europe, where American bombers flew missions impossible for any German aircraft to match or counter. The Liberators came in their hundreds, delivering ordnance measured in thousands of tons against targets selected to systematically destroy German industrial capacity. They operated from bases secure against German retaliation. They replaced losses faster than combat inflicted them. They demonstrated every day through their presence that industrial capacity and strategic foresight had determined outcomes more decisively than battlefield courage or tactical skill. German test pilots who flew captured B-24 acknowledged American achievement while understanding their own nation's failure. The Liberator was no crude machine but sophisticated engineering executed with manufacturing excellence. Its 3,000-mile range wasn't lucky accident but deliberate design implementing strategic vision. Its production in 18,000 examples wasn't impossible feat but predictable result of industrial organization and resource commitment. Germany had never built anything remotely comparable, not because German engineers lacked capability, but because German strategic planning never required such aircraft until too late for development and production. The admission, extracted through direct experience that could not be dismissed or explained away through ideology, came too late to change outcomes. By the time Luftwaffe pilots flew Sunshine and understood what American aviation had achieved, Germany's defeat was inevitable and imminent. The knowledge had value only for historians attempting to understand how industrial democracies defeated totalitarian powers through superior strategic planning and industrial organization rather than battlefield prowess alone. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.